This is the topic 2, flow of electric current, in series circuit, and parallel circuit. An electric circuit is composed of individual components, such as dry cell, switch, light bulb, resistor, and they are connected to each other by conductive wires, or traces, through which electric current can flow. In the circuit, the wire is with very low resistance, and normally we take an assumption that its resistance is equal to 0. The purpose of an electrical circuit is to enable the current flow from the source of power to the load. The load can be a light bulb, fan, and etc. And we can use the resistor to represent the load. The resistor, with its resistance value, that can cause energy loss, which equivalent to the energy consumed by the load. This is an example of a question. A voltage of 6 volt is applied across a light bulb with resistance 6 ohm. Calculate the current flow through the light bulb. In this question, the resistance of the light bulb is from the filament. When the current flow through the high resistance filament, the filament temperature increase, and until it lighted up, the current flow through the light bulb is equal to the voltage across the light bulb divided by its resistance. It is 1 ampere current. Now, we talk about electric circuit components. The following are the examples of the electrical components that make up the electric circuit. About the wire. Wire is used to carry the current in a circuit and bring the charges from the power source to the equipment. Wire is made up of metal with low resistance. This is to reduce to the power loss due to the resistance of the connection in the circuit. Copper is with low resistance and is cheap if compared to other metal. So, copper is used to make wire widely. Wire is normally coated with electric insulator, which made up of material, such as PVC. This is to prevent the short circuit, when the wires are brought closer together. About the switch. Switch is a device to regulate the flow of electricity by interrupting, or diverting the current, from one conductor to another. About the dry cell. A dry cell is a type of electric battery, it commonly used for portable electrical devices. Light bulb. Light bulb is an electric device. It will convert the electric energy to light energy. Resistor. Resistor is the device with a fixed resistance. Resistors are used to reduce current flow, adjust signal levels, to divide voltages in a circuit. Variable resistor, it also known as rheostat. It is the resistor with the adjustable resistance, same as the resistor with the fixed resistance value. Rheostat are used to reduce current flow, adjust signal levels, and to divide voltages in a circuit. It consists of 3 pins. The pin in the center need to connect to the low potential difference side. Ammeter. Ammeter is used to measure the current flow in a circuit. To perform the current measurement, firstly, we disconnect the circuit. Then, we insert the ammeter in between the disconnected terminal, where the red port of ammeter connect to positive terminal side, and black terminal connected to the negative terminal side. Ammeter is installed in series with the circuit. Voltmeter. Voltmeter is used to measure the potential difference between any 2 points in a circuit. It connected in parallel to the 2 points that to be measured. Galvanometer. Galvanometer is used for detecting and measuring small electric currents. It is connected in series with the circuit during the measurement. There are 3 status of circuit. The first is closed circuit. A closed circuit allows an uninterrupted flow of electricity from the source of the power through the conductor or wire to the load, and then back again to the ground, or source of power. Ground is referring to the earth ground. The earth ground is with a lower electrical potential. The electricity is about to flow from the higher potential point to a lower potential point. The statement, back to the source of power, is referring to the negative terminal of the power source, at which negative terminal have the lower potential relative to the positive terminal of the power source. Current will flow from the positive terminal to the negative terminal. The second status of circuit is open circuit. An open circuit is the circuit with the disconnection between load and power source. The open circuit is the opposite of the closed circuit, at which open circuit do not allow the current flow within the circuit. The closed circuit do allow the current flow within the circuit. Sometime we also said the open circuit is an open loop, and closed circuit is a closed loop. The open circuit can be due to the opened switch in the circuit. It can be caused by the disconnection in the wire and breakdown of the component in the circuit. For example, the broken filament in a light bulb. Why there is no current flow in an open circuit? It can be explained through the Ohm's law equation. From the Ohm's law, we know that the current in a circuit is equal to the voltage applied, divided by the total resistance across the circuit. The total resistance in the circuit is equal to the resistance across the opening area, across to the light bulb and the resistor. We can assume that the opened part is with the very high resistance. For example, the V is 10 volt. The opening area is 1 billion ohm. The light bulb is 6 ohm, and resistor is 10 ohm. Based on the calculation, the current is equal to 0.00000001 ampere. This is a very small number, that it can be ignored. So it is 0 ampere. In fact, the resistance of the opened part should be an infinity big value. So, the current will be a 0 ampere. The third status is the short circuit. Short circuit is a condition that occurs in a closed circuit. Short circuit is an electrical circuit that allows a current to travel along an unintended path, without, or with a very low electrical resistance. This path can be simply a wire, at which the wires for the circuit use are normally have very low resistance. The current will choose to flow more through the path with low resistance, and give up to flow through the path with high resistance. From the Ohm law equation, we know that the current flow through a circuit is equal to the voltage applied, divided by the resistance across the loop. The total resistance of wires is very small, and almost equal to 0. For example, the voltage is 10 volt. And the resistance of the wire value is about the value that can be negligible. It will generate a very big electric current. Such a big current will able to cause a damage to the power supply. It will generate a high temperature on the wire. This will cause the wire coat get a fire. This explains why short circuit is dangerous to your house. The household fire can be due to the short circuit. Come back to the topic of circuit. What will be happened if the short circuit only occurs in the light bulb like the situation in the diagram? It will be no current flow through the light bulb, and no light will be generated. But it will still flow through the resistor. This is the three status of the circuit. We have learned about the status of circuit. Now, let's move on to the types of electric circuit. The first is the series circuit, at which the loads are connected in series. The second is the parallel circuit, at which the loads are connected in parallel.